on this computer. Share the screen. I'm back on the whiteboard and whiteboard is moving. All right, guys, take a look at the second question. Now, we got to remember from the previous question, that we have a random variable X that's normal with a mean of 24 and a variance of 9. Remember, this is the mean, this is your variance. And they're asking us to find the probability of X being greater than 31. So what you do is you draw the situation out. Your middle here is 24. Your sigma, as previously, is going to be the square root of 9, whatever that is 3. Happens to be a nice number. Now you locate 31, more or less. Huh? What are the odds of that being a bad number? It could be high. It wouldn't matter because you just keep it in memory in your calculator. So if it was like 5, your variance was 5, then obviously your standard deviation is square root of 5. So what? You just keep it in your calculator. The odds are very high that it's going to be a bad number. So greater than, what does greater than mean? It means shade to the right. Numbers that are bigger than 31 are to the right of it. So we want to find this area. So the first step is we do what? We do z equals to x minus mu divided by sigma. Always x minus the mean. So it's 31 minus 24 divided by 3. Well, 31 minus 24 is 7. 7 divided by 3. 7 divided by 3 is 2.33. 3. I got to go 3 decimal places in this class because our table allows us to go that far. So this, yes.
Is that table going to be used for every column ever?
In normal distributions, yes. Yes. So this depicts the following situation. 2.333, this area here. Now, just to be clear, our table does not find areas to the right. It's always areas to the left. So what you want to do is you want to find the area to the left of that. So you want to find phi of 2.33. And then you're going to do 1 minus phi of 2.333 to figure out the probability of z being greater than 2.333, which in turn equals the probability of x being greater than 31. So let's go to our table. First, go to 2.33. Tell me what 2.33 gives you. What does 2.33 z-score give you? Area, cumulative area to the left gives you. What is it? 0. Sorry, zoomed out. 0 what?
0.9902.
And then we have to go the extra decimal place, 3. What does it say? Add to it?
1. No. At the end, I like adding the 1.
Oh, what is it before? 2.33.
0.99.
0.1, and then you have to add the 0.0001 to it because of the so 0.9902. Great, but that's area to the left. Yes.
At this time, all senior students need to report to the school gym for our senior panoramic photo. All senior
Oh, there
students,
they went early.
please make your way down to the gym for our senior panoramic photo. Please take all your belongings with you, just in case we run into you.
Why would they run away?
So this is going to be 0.99. Phew, excuse me. Thank you. 0.1 plus 0.0001. This comes out to be 0.9902. And so this guy here is going to be what? 1 minus 0.9902, which is 0098. So now we have 1 minus 0.0098. Oh, sorry. I'm messing up there. This is 0.9002. So it's 0.0098. And that is your answer, isn't it? So the probability of X being greater than 31 must be that. Are none of your teachers are using the surface?
I think I answered the question.
Tell me it's not cool.
Well, earlier you were complaining.
Yeah, because it was acting up. I also was complaining about Microsoft Whiteboard. Why would they take a perfectly working tool and mess with it? So, any questions or concerns? All right, so let's do the last one, and then I'll give you some classwork / homework to do so you can practice this. Starting next class, we'll begin doing is reviewing. We'll review. No, this is as hard as it gets. We'll start reviewing backwards. Okay, so we'll do the stats stuff from chapter 9. We'll do a question from stats, chapter 9, and we'll do a question from pure math. But now we have to go into the chapters we didn't really do, like trig, and work on that, and we'll work backwards.
I got here, I just busted.
Some people don't understand stats.
I prefer pure math.
Stats is easy. I think stats is easier.
What? I think
Just think about what we're doing here. Compare.
Guys, we're literally finding a number on a chart that is already. No. Pure
Think,
math, you
all
have
right,
to remember
think
the
about it
equations.
for a
Imagine
second.
having to remember these equations that you take the I'd rather do that.
Well, but once you start understanding stats, you'll realize how less challenging it actually is in comparison to algebra or geometry or.
No, don't get me wrong. This looks so much easier, but my brain is just not wired.
You're right. For a lot of people, when they start, when I started doing stats, I found it like I would do the class and I'll get an A, but I would have no idea what I was doing. But now I kind of understand it. So kind of, I can understand more if I wanted to. All right, so let's take a look at the problem number 3. I guess it gave the same. Really? Or I must have copied it wrong. Let me make sure. I don't want to give you something that's wrong. I must have copied, it must have a different mean, and I doubt they would give you the same mean, and that would be very, very strange. So let me just make sure I copied it right. No, it was 50 and 16. So let me erase that. 50 and 16. Now, instead of me just doing this problem from beginning to end, what I want you to do is I want you to use the previous problem to model it, and I'll do it, but I'll just do it in pieces. So right now I'm going to pause the recording and hopefully not press stop. I'm recording. Okay, so as you've seen, I've drawn the normal distribution there with a mean of 50 and a sigma of 4. The square root of 16 is obviously the standard deviation. Remember, this is the mean, this is the variance. Don't ever confuse that, because some people will just, without thinking, just pretend like the standard deviation is 16, and that's not the case. That's the variance. So you have to square root that. Now, to model this properly, 54 will be somewhere around here. Who knows? This is just so it can guide you. And these are X's, okay? And they want the area in between. So now, because you have 2 X's, you have to find 2 Z-scores. So the Z-score is going to be, well, remember, it's X minus mu divided by sigma. 54 minus 50 divided by 4, that's going to be just 1, right? And then you have 58 minus 50 divided by 4, that's 2. So what we have is we have 2 and 1, like that. 2 and 1. And well, you're going to find both of these areas here. Now, what did 2 give you? What did 2 give you? So if you go to 2.0 here, it gives you 0.9772. And if you go to 1.0, it gives you 0.8413. So therefore, the probability that X is less than 58, but greater than 54, is modeled by the probability of Z being less than or equal to 2, greater than or equal to 1, which is going to be equal to the phi of 2 minus the phi of 1, which is going to be 0.9772 minus 0.8413. Does that make sense?
Yes.
0.9772 minus 0.8413. It comes out to be 0.1359. And that is this area. Therefore, that reflects this other area here, which they are the same. We're essentially using the normal distribution to describe all potential normal distributions of different means and different sigmas. Remember, the standard normal distribution, is the distribution whose mean is 0 and whose standard deviation is 1. That is our standard normal distribution, which we're using to model all normal distributions, as long as we use the z-score formula to standardize the scores. Does that make sense? That's all we're doing. Make sense?
Yes.
Okay, I hope you understand how to do this. So I'm going to give you some classwork / homework to do. And next class, we start reviewing for the exam. And everywhere I can build on this, I'll try to build as best as I can within the limited time we have. I gotta shave and stop recording.